Hey guys, so I'm going to be going over the quantities for the constant velocity unit. Uh, if you want to find this page, it's on the intro notes and worksheet 1. And this is probably going to be broken up into 3 or 4 videos, so we'll be on this page for a while. This first lesson is over these definitions that are going to follow us throughout this unit and really into many units in the future. This is the foundation of this Newtonian physics we're going with. So the first quantity I want to talk about is distance. I'm going to close this. So you can find this on intro notes and worksheet 1. So the first quantity is distance. And what I want y'all to think about is distance. The way I would describe it is the actual path taken for an object. The actual path taken. So distance is a position term. When you ask someone, when you're trying to ascertain a position for something, it's about where it is in the world, right? And the distance for an object is between 2 points. So whatever it takes you to go there, that's going to be your distance. The symbol for it is x, and the units for it is meters. Now, I want to note here, this being x, distance being the symbol being x, is why I emphasize so much to not write y equals mx plus b, because x means position, it means distance. So if you're putting x here, then I'm thinking when you have a graph like this, well, you're telling me that I'm plotting something that is y versus our position term. I don't want that. Get that out of there. Replace it. We'll have a graph later on using x, and it won't be on the horizontal axis, and it will be very confusing in a physics sense what that means. So distance is the actual path taken. I'm going to give you another term, displacement. Have you ever heard of people being displaced maybe? That's what you should be thinking for this term. So displacement is the shortest possible path. That's how I'll describe it. Now, if you look this up, you'll probably find different definitions. I think this is the easiest way to explain it though. So distance is what you actually do. Displacement would be the shortest possible path. If I think about, 2 points in the world, A and B, maybe I go up and then down and around, and from A to B, that's my distance. My displacement would be the shortest possible path, which between 2 points would just be a line, right? So it's going to be this straight line from A to B. The symbol for displacement, now this gets a little confusing, it's x, and we put a little bar above it, and we call this a vector bar. Talk about it. It also uses units of meters. Now, when I say they use units of meters, meters aren't the only thing that can be used for distance and displacement. This is what they call the SI units. If in physics, we default to meters. If you might see centimeters or millimeters or some other unit used, or maybe feet and yards, but for the most part, we're going to default to meters. Now, to better explain this scenario again, I'm going to give you an example. So I always tell my kids that I'm a runner, if they don't know that yet. I go to races, and one of the races I did with my brother is actually the half Ironman. So the half Ironman, we did this in Northern California. It's a triathlon. You have to run, you have to swim, you have to bike. And so, when you're packing for this stuff, it's easy to pack for running and swimming, but it's difficult to pack your bike and throw it onto a plane. So we had to drive up there. So we're driving up there, and we have several routes we can go. The fastest route is usually the first one they recommend is I-10 one. Sometimes it's 27, sometimes it's 26 hours if there's not that much construction there. It's 1899 miles. But we could see here, there's this option via I-40 West, 1897 miles. So maybe we can go that one. And so I asked my kids, which one of these are the fastest? And they'll usually go, the I-40 West looks fastest. When this shows 27 hours, this seems the fastest. Well, what if, instead of doing all these different paths, I take the true shortest path possible? We know it should be a straight line, right? So I give this example. What if we just flew there instead? Well, first off, it's a lot shorter, but that's because it's a different mode of traveling. But we could see here, we just avoid all the mountain stuff. We go the straight line. Now, it may not look straight. That's a That's because it's a 2D image about a 3D world, and that causes this kind of curvature here. The Earth is curved, so it looks like it's not a straight line. It actually is a straight line. But yeah, this would be the path I would take. So I go back to our definitions. When we think of distance, distance is like me driving that car, and there's infinitely many ways to go from A to B. I can go all the way up here and back down, or I can go all the way down here, or I can go like maybe here, or go back around. All these green ones are different distances, different paths I can take. They don't seem that efficient, right? The red one's a distance, but the blue is my displacement. When we think of displacement, think of a plane flying between 2 points, shortest possible path. I'm going to use this time also to kind of, I mentioned this is something called a vector arrow that's on displacement. So we have two terms I want to bring up, scalar versus vector. All right, a scalar is a quantity without direction. A vector is a quantity with, sorry about my handwriting, if you're used to my style, not the best handwriting, quantity with direction. So scalars don't have direction, and I'll give you an example of a scalar, and you can probably guess because I gave one the vector arrow and I gave the other one not the vector arrow. Distance is a scalar term. Displacement is a vector term. Now some kids have kind of a problem with this. They say, Mr. Erickson, distance, you're going this path, you're actually changing directions a lot, so shouldn't direction matter? Well, I'll show you why that's a problem in itself. So I go back to my Google Maps scenario and I show you one of my many paths of driving there. So let's say I take the I-40 West route. We see, it's the shortest one by 2 miles. Okay, let's go with it. So I start off, it looks like I'm going northwest, and there are different angles of northwest, and some are more north, some are more west. We can see I'm going, and this part of the road, I'm just going south. I'm not even going left, right, up. I'm just going straight south, and then I go completely west, and then I go north. And so wherever you are on this path, you're changing directions a lot. So direction is very hard to use in distance because depending on where you are on the path, it's going to change. But I go back to my displacement scenario, and I see it's just a straight line. And it just goes northwest. No matter what part I am on this line, it's northwest. So I go back to my scenario here. Distance has no direction. It's just a number. When we say quantity, it's just a number. Maybe it's just 1899 miles, 1897 miles. A vector is going to be, let's say, 1,500 miles. So I go back to my plane. Let's say this is 1,500 miles northwest. That would be my displacement. So I think I'll stop the video here so it's not too long and continue with the quantities in the next lesson.